Okay, whether my voice is audible? Voice is audible. आवाज येतोय का नाही एवढं तर कमीत कमी सांगू शकताय. Okay. Then next we have studied the formulas related to the what I can say, how to find out the values of the current. Okay, so primary current and secondary current. So what will be the formula for finding out the value of primary current, which is nothing but the kVA into what I can say 1000 divided by V1. V1 primary side voltage, I2 kVA into 1000 divided by, it is nothing but the V2. Okay, then from this, how to find out the area of the cross section on primary side? We have seen the formula I1 divided by this delta, where this delta is nothing but the current density. And from secondary side, how to find the cross section area? I2 divided by delta. So how to find out the value of I1? I1 value you have to find out this formula, and I2 value you have to find from this formula. Whatever this delta is there, that is already given into the what I can say formulas. So just you have to use this formula. You have to find out the value of primary current. Okay, and this is nothing but the secondary current. The value of secondary current that you need to find out. And after finding out this value I1 and I2, you need to find out this value of A1 and A2, cross section on primary side and cross section on the secondary side. Okay, so this is the formulas related to how to find out the value of I1, I2, A1, A2. Okay, after that we have studied the very important formulas which are somewhat difficult for reminding. That is nothing but the formula related to the design of the tank of the transformer. Okay, formula related to the design of the tank of the transformer. So which are that formulae that which we have studied? First, sorry, this design of the tank, or what we can say design of the cooling of this tank. Okay, so first and important, that is nothing but the specific heat of radiation, specific heat of radiation for transformer sorry, for transformer is what I can say, which is a standard value 12.5 watt per meter square per degree Celsius. It is given into the example. If it is not given, you have to take it as the constant value, which is nothing but the 12.5 watt per meter square per degree Celsius. Okay, next we have studied the very important formula, that is nothing but the how to find out the watt value of the watt. So which is nothing but the what I can say, specific heat of radiation, specific heat of radiation into the temperature rise, into the temperature rise, which is given by the letter theta. Okay, next we have studied the formula for what? Another formula for this watt, which is nothing but the, how was that formula? 8.78 plus 3.72 divided by x into given temperature rise, into given temperature rise into the x into the s suffix small t, where this x is nothing but this constant st, s a suffix small t, this is nothing but the area of that particular tank, and this is nothing but the given temperature rise which is given into the examination. Okay, now what I can say, next formula that which we have studied area of one tube, which is nothing but the pi dl. Okay, where d is the diameter of that tube and l is nothing but the length of that tube. Okay, now if we don't know the length, then we have studied the formula for finding out the total length of tube. Total length of tube is 84% height of the tank. 84% height of the tank. Okay, and if I have to find total area of cooling tube, total area of cooling tube, so what will be that formula? That formula is nothing but the ST into bracket x minus 1. Okay, where this ST is nothing but the area of the tank and x is nothing but the constant whose value we are going to find out by using this formula. Okay, and the last important formula that which we require many of the time, that is how many number of tubes which are fitted there, that is nothing but the total number of tubes, which is equal to total area of cooling tube, divided by area of one tube, okay. टोटल एरिया ऑफ आता हा फॉर्म्युला काय असणार आहे, टोटल एरिया ऑफ कूलिंग ट्यूबचा फॉर्म्युला काय सांगितला, ST into x minus 1 आणि एरिया ऑफ वन ट्यूब काय असणार आहे, that is nothing but the pi dl. So this formula is very important, that is nothing but the total number of tubes, because whenever we have solved the example related to the design, what they have asked that how many number of tubes are fitted into the that particular tank, so that proper cooling arrangement will get satisfied. Okay, so for that you have to use this formula, that is nothing but the total area of the cooling tube divided by area of the one tube. Okay, so this is the as far as what I can say, whenever into the design of the tank of the transformer is given, whenever they have given this such that the dimensions of the tank are 125 into 100 into 50. So how much it is given? It is nothing, first is nothing but the height, second is nothing but the what I can say, it is nothing but the length, and third is nothing but the what I can say, width. Okay, and as far as if I will draw the 3D view, so what I can say, see here, that tank, if I will draw the tank view like this, okay, so this is the what I can say, this is the height, this is the width, and this is the length of that particular tank. ओके, हे माहित पाहिजे सगळ्यांना. हे जर व्यवस्थित कळलं तर आपल्याला पहिला जो पॉइंट आहे आपण डिझाइन मध्ये फाइंड आउट करतो, व्हॉट द टोटल एरिया ऑफ द टँक, हे जर व्यवस्थित माहित असेल ह्या तीन गोष्टी, देन इट इज इझिली पॉसिबल फॉर अस टू फाइंड आउट द व्हॉट वी कॅन से एरिया ऑफ द टँक. Okay, so this is nothing but the formula related to the what I can say cooling of the transformer, or you can say design of the tank for the cooling of the transformer. Okay.